Welcome. This is part 1, lecture 4. Part 1 means we are discussing now or considering engineering mechanics. Part 1 is for forces, moments, resultant, etc. See, now in the class I got some limitation. In the YouTube, when I upload, the title all, I cannot write too much details there. Even thumbnail also I cannot write. So what all I tell in the class you note down. But one small information, in the notes it will be not that way. Some other pattern will be followed so that correctly will be knowing what is going on systematically. And for your information, the first part of the notes is ready now. Nearly around 50 pages. So I already informed earlier, uploaded a class, those who want the notes, how to get it. So more I won't talk. So after this class and one more class, that much will be covered in the first part of my notes, around 50 pages. So as soon as this class is over and one more numerical part is over, where more and more important concepts are covered, I will take one small announcement I will make. Separate class. Class means separate video you can call, but I call class only. Regarding that notes, right now I won't tell anything. Okay. Now, today's class is very, very important. Complete explanation for application of law of parallelogram of forces. Remember, we already considered the statement. We explained that one, or I explained rather, or okay, you are also involved. We all know about it. And expression for magnitude and how to get the direction, that is alpha 1, alpha 2, all are explained. That all you have to make fair copy. Now, we are ready for application, including concepts. I will tell some concepts here one by one. A confusion in sign. I will give complete explanation for confusion in sign. See, when I tell confusion in sign means, I will tell what confusion you will get and I will remove the confusion. It is not that I will create the don't think that way. Including concept, confusion in sign when we get negative sign for alpha, alpha 2 and clarification for it. Clarification for it. So that you correctly understand. Then also some do's and do nots. What you should do and what you should not do. See, basic subject. We will not go in a hurry. Systematically we will cover. So that later, anybody who will go through this course, he should get 100% grip on engineering mechanics. That way, for strength of materials, structure analysis, and if everything goes okay, RCC, steel, etc., complete structure engineering. Okay, now, first statement of law. Law means law of parallelogram of forces. See, already given in part 1. Part 1, lecture 2, not lecture 3. Lecture 3 last time was some, what I told is particular cases. Lecture 2, see there, write it first. I won't write that one once again. There, because already written. So write it. I will just, for your understanding, dictate once. Law of parallelogram. See, I will not write anything here. Law of parallelogram of forces. If two concurrent forces passing through a point can be represented both in magnitude and direction by the two adjacent sides of a parallelogram, then their resultant is represented both in magnitude and direction by the diagonal of the parallelogram passing through that point. Then I told later, see, not only statement and explanation, let P1 and P2 be the two forces passing through any point, say O, making an angle theta between them. I have put a sketch earlier. Let R be the resultant for the two forces, resultant force. Let alpha 1 be the angle made by the resultant with the force P1, or alpha 2 be the angle made by resultant with the force P2. This is all I told. Then R equal to square root of F1 square, P1 square plus P2 square plus 2 P1 P2 into cos theta. I will tell why I told F1. In steel structures, when you go for eccentric connection, we don't call P1, we call F1. I solved plenty of questions. Suddenly it came to my mind. So root of P1 square plus P2 square plus 2P1 P2 into cos theta. And angle made by the resultant with any one of the force, either alpha 1 or alpha 2, is given by tan inverse of numerator other force into sin theta divided by that force plus other force into cos theta. Therefore, if you want the angle, see, I am explaining all without writing anything, not by hearting. I can see it somewhere. Where means to the inner mind I can see it. Let alpha 1 be the angle made by resultant with the force P1, tan alpha 1 or alpha 1 equal to tan inverse of P2 sin theta divided by P1 plus P2 cos theta, or alpha 2 equal to tan inverse of P1 sin theta divided by P2 plus P1 cos theta. This all I told. Okay, now, already given, write it. Next, some conditions or requirement. It is very, very important. I see, in the class I am going to dictate. I am not going to write everything by statements here. As I told earlier, this I cannot keep on telling. In that class, when I upload the notes, when I give details of the notes, how to get it, there I will tell last time. Then I will stop telling it. Otherwise, people will think he is promoting his notes. I am not that type. Here, see, I will dictate. Those who are depending only on the class, that is, they are not going for getting the notes from me, they should listen carefully, stop, pause it, then sometime have to go back, slightly backwards, see what I am telling, statement by statement, they should write and prepare the notes. It is their choice. Already I am conducting the class in full details. See, if I dictate something, it is duty or it is the duty of the person who want to learn to write everything. But it will be laborious process. That is left to you only. So, now I told conditions or some requirement. See, condition number 1 I will tell. Or require anything. 1. When you apply law of parallelogram of forces, the expression given for R, root of P1 square plus P2 square, etc., and expression for alpha 1, alpha 2, you can consider it or apply it provided both the forces, see, dash, 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 you should write, both the forces are either acting away from the point, or they should be acting or both should be acting, you should write it, acting towards the point. That is, I will write here, see, if one force is this way, any one P1, other P2 this way, see, both are acting this way, angle is theta, yes, you can apply. Or, if, see, I have not taken P1 horizontal. For derivation purpose, for easy understanding, I have put one of them this way. You imagine turned. I never told P1 is along x-axis. See, or if P1 is this way, then P2 should be like this. Okay, then also, okay, theta. Now, in that case, how resultant you have to mark? See, resultant should be marking, then resultant R should also be marked in the same way. Means, see, this way. Write one more sketch. First you write, passing same point, first you write these two sketches with the black. Then write one more sketch where show this one light line and mark the resultant. Okay, this is the requirement. Or make a note, if one force is this way, P1, and other force is this way, actually in the sample of notes they are given P2, and if you take this is theta, sorry, no. You should not apply law of parallelogram forces as per the format given. Not correct. It will give wrong result. But not that this you cannot apply. You have to change it. How to change it? You have or change it or not change the question. You have to make slight modification. What modification you require, I will explain little later now. I will tell, see, do's and do nots it will come. What modification you require, I will explain in the second round today. So make a note, modification required. And then one very important note you have to write. See, one force going this way, one force going this way. So many people will tell, oh, when you apply law of parallelogram forces, the forces should be in the first quadrant. See, you usually call quadrant 1. No, there is no such rule. Any way you can consider the forces, whatever way we want. I will show it here now. Then I will remove this one. See, you write here. After this all you have to write. See, there is no restriction. You can apply the law. See, if one force is this way, P1, other can be here also. P2, say theta. Or if one force is this way, P1, other can be this way also. P2, theta. Or if one force is this way, other can be this way also. P2, O, theta. But then, how resultant your mark? See, point O. But one thing, both should be outgoing, or even see, or one can be like this, other can be like this also. Okay, no problem, done. One of them P1, other is P2, done, you can apply. But resultant also you have to mark. See, I don't know which side will go because depends on which is more, randomly I will place. Resultant R. And remember now, when you mark angle alpha, how to mark? See here, with the P1. See, from P1 you will start. Alpha 1, alpha 2. See here. Alpha 1. Don't see clockwise, anti-clockwise. Start from the force and mark resultant. Alpha 2. See here. See here. Alpha 2 this way. Never think that way, that alpha 1 is anti-clockwise or clockwise, nothing like that. Or see, one more I will write here. Same, going towards the point. I will see that alpha 1 is clockwise. P1 I will take this one. Okay, I will let it go inside. Okay, go inwards. Just like that. P1 I will take this way, point O. P2 I will take this way. You should see, once you take P1 this way, P2 cannot be taken this way. Then, see, this is the theta. See, I will mark here. This is your theta. Now, resultant R. See now, for P1 it will be this way, clockwise. For P2, it is alpha 2. That way you have to mark. So, when you mark angle alpha 1, alpha 2, never bother clockwise, anti-clockwise. See, definition, angle made by the resultant with P1 or P2. See, when you tell angle made with horizontal, you start marking from horizontal. So, in all the cases, when you tell alpha 1 is the angle made by resultant with P1 means start from P1, go to R. Alpha 2, start from P2, go to R. That is the rule. Okay, now, one round is over. Now I will tell you, okay, now, see, for all these cases, I will write expression, it's already known for you. Somewhere here I will write now. For all this one, your answer is, see, your answer is R equal to, actually already over, square root of P1 square plus P2 square plus 2P1 P2 into cos theta, and alpha 1 is tan inverse of P2 sin theta. This all I explained very thoroughly. How to remember? Divide by P1 plus P2 cos theta, or alpha 2 equal to tan inverse of P1 sin theta divided by P2 plus P1 into cos theta. That is anything, both are the same. Tan inverse of other force into sin theta divided by that force plus other force into cos theta. Now, one important, I will make a note. Many times, see here, P1 is square, P2 is square, positive. Cos theta, you always, usually you take theta within 180 degrees. Because I will tell one more concept here. See, suppose one force is here, other force is here. You take this is theta. But if you take this as theta, it is 360 minus theta it becomes. Cos 360 minus theta is once again equal to what? Becomes once again cos theta. You know it. Therefore, when you substitute here, you will not get negative. R will always come positive. But what happens is, when you substitute and get alpha 1 and alpha 2, sometimes you get a negative sign. I will tell you what to do for negative sign. The complete concept of negative sign, I will explain now in the coming part now. I will explain that one. Now, I will remove all this one. First, I will tell one force is outgoing, one force incoming. Then what to do, I will first cover that one. Just a minute. See, just a note. As already explained, waves means you should write for application of law of parallelogram forces and for considering the expressions for resultant R and angle alpha 1, alpha 2 as per the given format. That's very important. I won't tell how again and again that format R equal to square root of alpha equal to tan inverse of. I won't tell now that one. Both forces should, it is compulsory, right here. It is compulsory that, very, very important. It is a compulsory that, continue here, for application of law of parallelogram forces and for substituting in the expression in the standard format given by me, not by me, everybody will give same thing. Then it is compulsory that both forces should either act away from the point or act towards the point. See here, both which is P1, which is P2 not required for us now. See, both are acting away. Okay, and or both are acting towards. Do one thing. Here, let beta be the angle given. See, I'll put here now. You can make a note here. Let beta be angle given in the question. Given in question. Right here. Yes, we can apply the law. Then your theta will become beta. Beta means some angle they are giving. In our expression for R and alpha, we use theta. That angle theta should be substituted if this given angle. Why? Because yes, condition satisfied. Either both are going away from the point or both are coming towards the point. Then I told you how to mark resultant. If you want, write one more sketch. You should mark resultant like this. Here, mark resultant like this. Mark this way. Yes, then your theta to be used is whatever angle beta. Or, I will tell, in simple language, both should be easy to understand. See, both should be either incoming or outgoing. Some student will tell, sir, acting away from the point or acting towards the point. Sir, instead of that way, this is best, sir. What best? Sir, either both are incoming or outgoing. Okay, see, either both are outgoing with respect to the point or both are incoming. Yes, you can apply. But suppose in a question, either competitive examination or any question or practically also, see, by chance, practically also, you get one force like this, one more force like this, some truss member or any problem. You should not apply the law. It will give wrong result. So, but or simple language. But suppose in a question, one force is given as acting away from the point or and other given as acting towards the point. Means, or simple language, one of them is incoming, other is outgoing, with angle with the given angle beta between them. How? Right here, as shown here. See, here, one case. I'll put case 1 here. Case 1 here. I'll put case 2 here. Case 2 here. See, case 1. P1, you write, those who are serious should write all these things. See, I told in the notes I write everything by words. See, case 1, right? P1 is acting away from the point, P2 is acting towards the point. Or simple language, P1 is outgoing, P2 is incoming. No, you cannot apply, you can still apply, you cannot use or use the standard format we considered for R equal to, see, R will be acting something like this, angle alpha beta. That is wrong. It will give wrong result. What to do? Wait for some time. I will tell you. Or, see, one more case 2. Here, right here. P1 is acting towards the point, P2 acting away, or your simple language, P1 incoming, P2 outgoing. Yes, here also no. Some people will tell, we can apply, I know we can apply, but some modification required. Therefore, here also, our standard format you cannot use, some modification required. So I told you case 1, case 2, see, this can turn also, and remember, beta is the angle given in the question. This beta, remember, this beta will not be theta if you take as it is. Or I will explain now, 1 minute. Of course, this beta can be theta on a condition. 1 minute, wait for some time. Okay, now, see, this incoming, outgoing, condition, do's and do nots, these are all simple to understand. My purpose is to educate and see that everybody will understand. I will tell one thing. Like I told earlier in one of the classes, that is in that special brain teaser class, first learn to walk, then practice running. First learn to walk, then practice running. Or mathematics, first learn number system. First learn how to add and subtract, divide and multiply. Understand the basic meaning of addition, subtraction, division, multiplication, then go for higher mathematics. Without knowing that one, or trigonometry, first you understand what is sin theta, what is cos theta in a right angle triangle. First you go for a property of a right angle triangle. Understand. Then you go anywhere. Even differentiation, integration also. First you understand what is a function, what is a variable. Once you understand that all, then learn. Directly don't go there. Therefore, my purpose is to make everything clear. People who learn later, they can extend their knowledge, they can improve, they can become champions or expert in a subject. Good. If anybody will learn from me and tomorrow if they become very popular or if they shine in the structural engineering field, I'll be very, very happy. Otherwise also, I will never feel jealous. If I see a person who got very good knowledge, I appreciate. I will not feel jealous. Oh, he is having more knowledge than me. No. If I require, I will learn from him. If at all it happens. Therefore, simple language. See, people will be there who comment. He tells us, see, incoming, outgoing, he uses those words. For them, only one thing I will tell. Either come in front of me and talk. I will tell you how to talk technically, pure technically. Or in the YouTube, I am uploading class after class there, brain teaser, etc. Answer all the questions. If you answer all the questions, then come to me. Then, in case I find that you got a better knowledge than me, I will learn from you, no problem. I will not feel jealous. I will tell, okay, please teach me also. I will learn from him. If that situation comes, my students will be knowing whether the situation will come or not. Therefore, never bother about unnecessary, what you call it, ego system or standard all. Standard comes when you learn. When you learn in the beginning, you should learn in a simple way. That is why even I am famous in the structural engineering teaching in Bangalore here. For the main reason is they will tell KSN always gives you simple way of explanation. Of course, they tell he knows much, much more. He can talk technically. And one more thing I will tell, number only. Little later, I will upload a class, pure technical. I will tell those who comment on the simple language I am using, then you go through that class, then tell whether that comment still valid or not. One fine day, I'll upload a class. I will tell not for general public, only for those who doubt about my capacity in the technical knowledge. I will go pure technical. Then they will realize that not that I am not knowing all the technical matter, but my purpose is to educate and teach in a simple way so that everybody will understand. Okay, leave it now. Now I will come to more explanation for, see, case 1 and case 2. I will give you more explanation, and also I will tell you, I told directly you cannot apply, you require modification or some alterations. I will tell what is that alteration. Okay. Now make a note. Modifications or some alteration you can call, or you can call adjustments. For applying law of parallelogram of forces in the format given by me, when one of the force is acting away from the point, other is acting towards the point, that is a given question with angle beta. See, that is case 1. See, I won't call P1, P2 because our P1, P2 is changing now. Don't use P. This is a question given right here. This is a question given. See, there is no P1, no P2, no theta. Numerical, 30 Newton, 80 Newton, 40 degree, like that. So imagine one force F1 given this way, F2 given this way, or one force F1 given this way, F2 given this way. Make a note here. F1 is outgoing, F2 is incoming. You can make a note. Or F1 is acting, or how many times I have to tell, away from the point, F2 acting towards the point. Here, F1 is acting towards the point. F2, F1. F2 is acting away from the point. F1 incoming, if you stand here, F2 outgoing, given angle is beta, case 2. Now, 1 minute now. There are 2 options for you. Later I will tell which is the best option. Both are okay. Option 1. Extend one of the forces, any one of the forces, so that both are either acting away or acting towards the point. You extend one of the forces to other side so that either both becomes outgoing or both become incoming. Then remember, your theta is not equal to beta. What angle given here is not theta. We have to get theta. One of the options. Option 2. Consider both to be acting either away from the point or towards the point. Even if they give one acting away, one coming to the point, you consider both of them to be either acting away or acting toward. Somebody will tell, sir, how possible? Wait for some time. Option 2. Then, but we have to consider negative sign for one of the forces. I will explain thoroughly which force. Then your theta becomes beta. And if you make that way, then your theta becomes beta only. See, I written here, nothing to, sometime it happens, when all things are told in the class, students will tell, sir, a little confused. Nothing to worry. Both will be fully explained. I will ask them, did it ever happen that I told something or solved a question without making clear for you? No, sir. When you solve a question, sir, everything crystal clear. Yes, wait. You are hurrying. Don't hurry. Wait for some time. I told nothing to worry. Sometime in the beginning, confusion comes. I will tell, for example, simple matter. There is a method called Kani's method. When I tell the statement there for Kani's method, I will tell rotation contribution at any joint for a particular member equal to respect rotation factor times sum of FPMs of all members meeting at the joint plus sum of rotation contribution of all the member meeting of all the members sum of rotation contributions at the far ends of all the members meeting at that point. Or I will tell some other times, if sway is there, rotation contribution at a joint for a particular member equal to respective rotation factor times sum of FPMs of all member meeting at that point plus sum of rotation contribution at the far ends of all member meeting at that joint and also sum of displacement contributions of all the columns meeting at that point. People will tell, sir, what is this? Wait. That is a statement. I will ask the same students after 1 or 2 problems over. Now, sir, clear, sir. Why? Sir, because when you solve the question, systematically it is solved crystal clear. Therefore, wait. I always will tell in my class, don't hurry. Suddenly don't think something written here, not clear. You tell not clear when everything is over. Not only theory. After all this, when application comes, these all I will consider in the application. See, very important for competitive examinations. When everything is over, then you comment. Not clear, not now. You have to wait till I complete this part. Sometimes it happens. Initially, confusion will come. It will vanish like anything. Like when sunlight falls, what mist, etc., everything will be cleared. See, in the early morning, mist will be there. But as the sun rises, finally, everything clear. Knowledge will improve. So, wait for some time. Now, correctly see this one. I am going to remove the full board now. Remove means rub the full board and clearly explaining this case and this case. Therefore, here, this I do not want. I want complete board here. So, this I will not remove. This full I am removing. Correctly, anyway, write it first. Okay. Now, I will start last part of today's class and regarding sign for alpha, negative, positive coming, I will explain now. But whatever way I explain, there will be confusion. That I will clarify with a special note when I take up examples. Just I will clear these two first. Okay. I wrote this much only. Okay. Right here. Modifications for applying the law. Dash dash means you are right. When you can make a small heading, when one of the force given is acting away from the point and other is acting towards the point, or you can tell one is outgoing, one is incoming, anyone, then directly you cannot apply. Some angle will be given in the question. That is the angle they are giving. So then what to do? I will tell one case here. See, this F1, I am not calling this as what? PQ or P1, P2. F1, F2. F1, F2. Here, make a note here. F1 is away, F2 is towards. Or your simple language, F1 outgoing, F2 incoming. Given angle is beta. Or here, F1 incoming, F2 outgoing. Or F1 acting towards the point, F2 acting away from the point. See, these things all, I am not telling very slowly. There are two reasons. It's a transition period. I remember in the beginning. Later, usually I go for usual way. But I am not talking very high speed. Slowly I will change the pattern so that later I will talk this way. See, F1 is acting towards the point. F2 is acting away from the point. I will slowly change out that pattern. It will take some time. Okay, now, what to do? First, to take this case. Right here. Case 1, what to do? See, what to do? I write here now. What to do? Okay. What to do, right? So that we can apply the law of here also. What to do? What to do so that we can apply the law of parallelogram forces in the given format by me. Okay, start. First this one. Option 1, just now I told. extend one of the forces. See, what all I am telling now, you have to write it. I will do one thing now. See, option 1, you write here. I will maintain F1 as it is. F1. I will maintain as it is. F2 is acting towards the point. Since I took F1 acting away, F2 should be acting away only. So your original F2 is here. See, this is your F2. How they given F2? See, you should write it. See, F2 is given like this. See here, this way. What you do is, you extend it this way. F2. Now, see, if you write the same F2, we are not changing direction, marking other side by pushing other side. Now F1 going away, F2 also going away. Now this will be your theta. Theta, and this theta will be equal to how much? If this is beta, this is 180 degrees, the theta you have to use is 180 minus given beta. Make a note. Now take a red color, write one more sketch if you want. One more sketch. Now resultant, you have to mark this way. See, actually not required because, no, leave it now. I will show it here if you want. Now, see, once you write this much clearly, then write one more sketch you write. There you write, now resultant, you have to mark this way. Angle, see, this is your alpha 1, this is your alpha 2. Anyway, nothing to worry. One more sketch you have to write. Otherwise, it will not be clear for you. First you write the construction, then write one more sketch. Anyway, this all I am clarifying when I solve numericals. Okay. Or, still not over, this option 1. See, 1 minute here. Still or, incomplete. Or, one more option 1 option here. Or you can do one thing. You maintain F2 as it is. Incoming. Okay, no problem. F2 incoming. F1 is given like this. See, this way. This is the point O. See, actually ink is little. Okay. Or one more, not option 2, option 1 only, one more way. See here. F2 you take as it is. F2. F1 is given like this way. You make it this way. F1. This is your F2 as it is. So now F2 is incoming, F1 also make incoming. Now that is your theta. Again your theta equal to 180 minus given beta. You write this much. Then you write one more sketch. Now resultant, you have to mark not this way, you have to mark resultant like this now. Why? See? This way. Resultant are, now this angle will be beta 1, sorry, not beta 1, alpha 1. Okay. Alpha 1, this angle will be alpha 2. Okay, over. This is for this case. Same if I go for this one. Okay, I will go. Okay, now only I will tell it. See here, see. Option 2 I will tell you little later. Option 2 I will tell little later. For both of them. Here, go here. Option 1. F1 is given like this. F1 given here. Maintain F1 as it is. F2 given this way. So, see, this way given. Make it this way. F2. In the same line. Now, this is a point O. This will be your theta. So that theta will be equal to 180 minus given beta. Now, resultant, you should not mark this way. You have to mark this way, resultant. As usual, this is the angle alpha 1. See, this is the angle alpha 2. Or, one more option. Maintain F2 same way. Same way. F2 same way. F1 is acting this way. See, shift it here. F1 here. In the same line. This is your given beta. Now, this will be your theta. So, once again, your theta equal to 180 minus beta. Now, resultant, you should mark this way. Resultant this way. One more sketch you have to write. This is the angle alpha 1. In case by mistake, if I wrote anything wrong, by chance, I think everything is correct. See, suppose F2 is alpha 2. In a hurry, I think correct alpha 2, alpha 1. People are there who want to find mistakes. This is option 1. What you do? One of them maintain as it is, other you take other side so that either both are incoming or both are outgoing. This is one of the options. Now I'll go to second option. Second option, what to do is maintain same way. Same way. See here. F1 is option 2. Okay. Second option now. See what I wrote earlier. One more option. F1 you maintain same way. It is right here as it is, F1. It is outgoing. See, with respect to point O, going away from the point. F2 is coming towards that one. Right here only. That also make outgoing. F2. F2. Now what you have to do is, you should not write F2 here, you have to write minus F2. Therefore, how to substitute, I will tell in the example later. You take this as F1, F2 is given this way, you take this as minus F2. Now your theta will remain same. This way is theta. Now resultant should be marked this way. See, resultant should be marked this way. As usual, angle alpha 1 here, angle alpha 2 here. Or F2 you maintain, see, F2 you maintain same way. This all will be clear when I take numerical. See how many numericals I am taking very slowly. F1 is going away. Make that also incoming. But right here, minus F1. Whatever F1 they told, write minus F1 here. Now, suppose they give 10 Newton here, write minus 10. Now this is your angle theta. Now resultant should be marked this way. See, this way resultant, angle alpha 1 here, alpha 2 here. Same way here. See, for second case, F1 you mark this way, as it is, F1, as it is. F2 is going this way. That also make this way. Okay, meeting point here, O. This is F1, this F2 is going this way. You write this as minus F2. Now your theta is this one only. Because why? Both are incoming. Now resultant, you have to mark this way. I won't show alpha 1, alpha 2, right here. Alpha 1, alpha 2. Or maintain F2 as it is. F2 as it is. It's outgoing, see, going away. F1 is coming this way. You make it this way, F1. But actually F1 is this way, so what you do? You write minus F1 here. Now this is your theta. Now resultant should be like this. These are the alteration. Nothing to worry, some disturbance is there, some dogs barking. Okay, we can't prevent it. It is midnight, still helpless. So therefore, hope it won't distract you. This is the arrangement you have to make, and then you can solve. And all this concept I will very thoroughly explain little later. Now I will give one last concept for you before I wind up this class. Means we are ready for application. Your every doubt will be clarified by the examples. No, I have not cleaned the board fully sufficient. Lastly, direction for alpha 1, alpha 2, that is confusion which may arise with respect to sign. See, make a note. When you find resultant R, see, I told p square plus q square plus 2pq cos theta. Therefore, whether theta is positive or negative, whatever is there, it is always positive. When you take cos negative is positive. So resultant R will not come negative. But very important, write a note. It is possible that either for alpha 1 or for alpha 2, both you will not get. Either for alpha 1 or for alpha 2, it is possible that we may not get negative sign in the result. in the result. When we substitute in the formula alpha 1 or alpha 2, see alpha 1 alpha 2 equal to tan inverse of, I won't write once again, tan inverse of this one. Now, correctly understand what is the sign. See, make a note. Positive sign or negative sign has nothing to do with clockwise or anti-clockwise. Very, very important. Later, I will upload one more class for entire engineering, not civil. Not only engineering, any science subject. It may be BSc or MSc or even civil, mechanical, anybody. Sign problem. Okay. That is a mathematical concept. Very systematic approach. But till now, has nothing to do with the clockwise, anti-clockwise. See, now remember, positive sign for either alpha 1 or alpha 2 indicates that the direction marked in the sketch. In sketch means before you calculate, see, before you calculate alpha 1, alpha 2, you mark that one. The sketch is correct. Therefore, if you get positive sign, now you write yourself, then mark that angle in the same direction. Never bother clockwise, anti-clockwise. In the same direction as considered in the sketch. Sketch means that marking. Okay. And positive sign for either alpha indicates. Now write here. Negative sign, you should write for either alpha 1 or alpha 2 indicates that the direction marked in the sketch is wrong. Therefore, if you get negative sign, then you have to consider that angle in a direction opposite to the direction considered in the sketch. Slowly I told, write it. Now write here. This one will be 100% clarified when I take examples. At that time I will give more and more note, because when you get result, then if I explain, it becomes more clear. Now if I continue further, people get confused. So leave it. So remember, lastly, that plus minus sign for alpha 1, alpha 2 has nothing to do with clockwise, anti-clockwise. Positive sign indicates what direction you considered is correct. So, same direction is correct, valid. Then mark in the same direction. Negative sign indicates the direction considered is wrong. So, when you write final answer, you mark the direction in the direction opposite to the direction considered. Or if you mark clockwise there, positive, yes, clockwise, negative, reverse, anti-clockwise. Suppose you mark anti-clockwise there. If you mark anti-clockwise, positive, correct, anti-clockwise, negative means reverse, clockwise. But nothing to worry. Complete this will be clarified very systematically. Maybe I will take more than half an hour for that one in the numerical examples. Okay, now class 4 over. Class 5 is real starting of application. Study thoroughly all these 4 classes and get ready for class 5. Thank you.